Kite problems tend to be some of the most difficult questions on these papers, and this one is no exception. It just gradually steps up as you go through. First part's not too bad, to be fair. And each time we're going to draw a really careful diagram. So I've got a fixed origin, and I'm going to point A, B, and C. Of course, this is in three-dimensional space. We're asked for the cosine of angle ABC. So if I connect that up like that, it's going to be this angle here. We'll call it theta. Now, I'm going to make vectors here in red, and then we can take the dot product. I mean, we don't know what these things are yet, but we're going to BA dotted with BC will equal the magnitude of BA times the magnitude of BC times cos theta. And there's another form for it as well, where you multiply the components, which we'll be able to use. So BA, let's work out that. BA, oh, remember, quite often I sort of call this like little a, and this little b. This helps me anyway. And this little c. They're kind of like little a is OA, little b is OB, and so on. So BA, then it's more easy to see it's going to be minus b plus a, or a minus b. So it's going to be minus 1, 4 over 3, 7. That's my a minus b, which is 4, 4 over 3, 2. So that will equal minus 5, 0, 5. BC is then going to be C minus B. So 6, 16 over 3, and 2. That's going to give 2, 12 over 3, which is actually going to be 4, and 0 here. So I'm actually going to write up here now, we're going to get the magnitude of BA. We can use 3D Pythagoras. It's going to be 25 plus 25 square rooted, root 50. And the magnitude of BC is 4 plus 16, 20 square rooted. Therefore, root 50 times root 20 times cos theta. And now I apply the dot product, so I multiply the x components together, minus 10, the y components together, 0, and the z components together, 0, and there we are. So this is actually going to equal the square root of, well, 50 times 2 is 100, so the square root of 1,000. So it's actually going to equal, you can take out the square root of 100, which is 10, it's going to be 10 root 10. And therefore, cos theta is going to be minus 10 over 10 root 10. It's going to be minus 1 over root 10. So part A is done. On to part B. We're told that the quadrilateral ABCD is a kite K, and we're asked to find the area of K. So first of all, I'm going to just draw a kite, and I'll draw it in a reasonable orientation as well. Let's say that O is over here. Now we need to think carefully how we label our kites. For example, we already know that BA and BC are not the same length, so you can't, for example, go BAC. That doesn't make any sense because BA is not the same length, and we know in a kite they would be. We also know that because the cosine is negative, then cos, remember cos is going to look like this. It's actually going to be obtuse. It's going to be more than 90 degrees. So it must be that B is either on the left or the right. And then we don't really know whether A is up here or C is here, but that doesn't really matter too much. It's okay if I get it the wrong way around. So I'm going to put A down here and C down here. That means that D is going to be over here. So I hope that makes sense. B can't be at the top or the bottom because it's an obtuse angle. It has to be at one of the sides. That means that A and C are going to have to be at these ends here, and therefore D is over here. This is actually, this is great, in fact, because we know what this angle is, and we can split the kite into two triangles. So we haven't actually got that much more to do. We can say that the area of the triangle is going to be a half AB sine C. Now remember, we know that BC is root 20, BA is root 50. So it's going to be a half times root 20 times root 50 times sine of B. Okay, that's the little bit where we have to do something a little bit more. But we can say that cos squared theta is going to equal 1 over 10. And therefore sine squared theta is going to be 1 minus that. It's going to be 9 over 10. And therefore sine theta is going to be the square root of 9 over 10, plus or minus technically. Now we just need to be careful. We can see that the angle is obtuse. So if we look at sine, we can see that sine has to be positive. Okay, it's not it's not gone beyond 180. So we will reject the negative. And we can simply put in that it's 9 over 10. Now that's the area of one triangle, but we've got two triangles. So I'm going to have to times it by 2, which cancels out that half. And now we just need to figure this bit out. So like I said before, this bit here is actually 10. This is equal to 10 root 10. So it's going to be 10 root 10 times root 9 over root 10. These cancel, and root 9 is 3. So I'm going to get 30. We don't know what unit we're working in, so I'll write units squared. Really tricky if you don't get your diagram right, and if you end up putting B in the wrong place, but otherwise this is actually not too bad as well. The challenge, however, is about to arise, in my opinion. C. A circle is drawn inside K so that it touches each of the four sides of K. So I'm going to start this off with a diagram. Same sort of orientation, and I'll label it A, B, C, D in the same way. And now we're told we've got this circle that just touches. It's actually very, very hard to draw that accurately. course, my kite is not drawn like super accurately. Okay, yeah, that looks pretty good, to be fair. Now, we're asked to find the radius, so I'm going to draw the center of the circle, and I'm going to put the radius in. Don't forget, because they just touch each of the four sides, that means that the radius is going to be perpendicular to these. CB is going to be a tangent. So I'm going to, because I don't know anything about D, I'm going to ignore it, and I'm just going to focus on this here and this here. I know that this will be 90 degrees, and so will this. Now remember, we have the area of the whole kite up here, 30. We can also find the area by splitting it down like this and thinking about two different triangles. And there's one line I've not yet put in here. So R is actually the height of this triangle here, and it's also the height of this other triangle here. Let me do that in a different color. And therefore the area of the kite is going to equal 2 times the area of, now I should probably call the center something. I can't call it C, so I'll call it capital X. It's going to be the area of BXC plus the area of BXA. And that's going to equal 2 lots. And we need to think about this carefully. Well, we've got base times height. So it's going to be the magnitude of BC times R. Oh, half of that because it's a triangle. So I hope that makes sense. It's a half base times height plus a half base times height. And again, this 2 is going to cancel out with this and this. This is the key to this question, and this, I don't mean to make it sound easy to get to this. Once you're here, it's you're okay, but it's realizing to do that. But maybe you managed it. Now remember, above we had that BC was root 20, BA was root 50. So root 20 R plus root 50 R, and that is equal to 30 from before. So I feel like I just want to recap. I've drawn the same kite. I've drawn a circle which it just touches each of the four sides. I've put the radius in, which I know is it's a 90-degree angle from here to here. Sorry, from 90-degree angle here, and there's one up here because it's a tangent. That's one of the circle theorems. I've then shaded this purple triangle where R is the height of BAX, and this green triangle where R is the height in some, if you reorientated it, of BXC. And then I've looked at these two triangles. I've said, hey, if I add these areas up and times it by 2, that will give me the area of the kite. The area of the purple triangle is a half times times BA times R, and the green triangle, very similar. I've added them up, times that by 2, cancelled out those. I know what these lengths are, so, and then I've set it back equal to 30 from before. So we're nearly there. I'm kind of tempted to, what goes into both of these? Or maybe nothing. Okay, let's leave that. Right, I'm going to leave it as it is. It's going to be R root 20 plus root 50 equals 30. Okay, we're on the right path now. R is going to equal 30 over, I'll write the 50 first, because now I just need to rationalize the denominator, and I'll do root 50 times, sorry, minus root 20. But I swapped it around because now this is going to be positive. Okay, I'm not going to expand these out quite yet. So I'm going to get root 50 times root 50, which is 50. Then it's going to be minus 20, and the other crossover terms are going to disappear. So that is amazing because that is 30, which cancels with this. And I'm left with root 50 minus root 20. Now we were asked to write it p and q are positive integers. Like basically we're going to be asked to simplify the third. Okay, this is looking good. So we need to think what square number goes into 50. Well, 50 is 25 times 2, so it's going to be 5. It's root 25, which is 5. 5 root 2. And then out of the 20, you can take the 4. So root 4, which is 2. And then it's going to be root 5. And we can be pretty confident at this point this is correct because you can see that they were swapping around. This is like a big clue in the question. That is the radius. One more part of this question to go, and there's definitely a big difference between understanding someone go through this question and being able to do it just like by looking at it in the time required. So well done if you've made any sort of attempt at this. To be honest, especially C and now D. Find the position vector at the point D. Do you know what? I might just what do I care about? No, I'm not going to draw the circle again, but we're going to be using aspects of it. Um, oh, actually, I don't think we are. So we've got CBAD. And don't forget, we've sort of got O over here. And we want to find out what this is. OD. Now, one way of doing it is to think, right, I'm going to actually go O to B. And then I'm going to go from B to D. I'm going to put a point here because actually that's what you have to realize to do in this question. So it's going to be, that's a Y rather than an X. Let me do that again. Plus 2 lots of BY. Now we know what this is, so this is great, but we don't know what this is. B to Y. The reason that I'm using this formula and not say O to C and then to D is like I don't have any information about C to D, but I do have some information about B to D because this is a kite. And if we draw a line going down from here to here, then there is a right angle between BY and CA. And that is the crucial thing we need for this question. Now, I can't remember, did we find out what AC was? No, we didn't. So we're going to need to sort that out. But let me write down key thing that we're going to use. BX is perpendicular to AC. And then AC is going to equal little c minus A, from similar to before. So 6, 16 over 3, 2, minus 1, 4 over 3, 7. which will leave us with 7, 12 over 3, which is 4, and minus 5. So that's AC. Now BX is, that's how on earth, we have no idea. We don't know what, sorry, BY. We have no idea where Y is. But this is what we can do. BY must equal, we've got to think about it as the equation of a line now. BY, well, we can go from B to A. And then we are going to go along some amount from A to C. That will get us there. Okay, we just don't know what this thing is, but if we know what that is, then we know what BY is. And that's where this is going to come in when we're going to use a dot product. So BA, we calculated it, I think, before, did we? Here we go, minus 505. And then we're going to plus T times AC, which we just calculated there. So that would be minus 5 plus 70, 4t, and 5 minus 5t. Now we can dot product them. And set them equal to 0, since they are perpendicular. So we've got this equation. I can add these up, so I'm going to get 16 plus 25 is 41, plus 49 is 90t. And then I've got minus 35 minus 25. That's going to be minus 60, which I can then add to both sides, so I get 60. So t is going to be 60 over 90, or 6 over 9, or 2 over 3. 4. And this is, yeah, this is good now. So therefore, by is going to equal, remember we had it here, we just need to substitute in 2/3, which is not particularly nice. So it's going to be minus 5 plus 14 over 3. And then 4 times 2/3, which is 8/3. And then 5 minus 10 over 3. And I can put this all over the common denominator. So this is going to be minus 15 over 3. If I add it, I'll get minus 1 over 3. This stays as 8 over 3. And this is 15 over 3. So I'm going to be left with 5 over 3. We are so close. Remember, we've got this. Now we had this one at the start, and hey, now we are like this. So OB, where's it gone? Right, okay, like all the way back up here. OB is going to be 4, 4/3, and 2. plus 2 lots of by, so minus 2/3, 16 over 3, and 10 over 3. So that's going to be 12 over 3 minus 2 over 3 will be 10 over 3. This will be 20 over 3. And this will be 6 over 3 plus 10 over 3, 16 over 3. Absolutely fine to leave it like that. You might take the third out to make it a little bit nicer. In fact, we could take more out. I could take a factor of, it's 2, isn't it? But I'll leave it like this. Okay, well done on your efforts on this question. Good job.